So here we're going to start looking at patterns. In particular, we're going to look at what we call linear patterns, and they take the form y equals mx, which just now will not mean very much to us, but once we finish this, we start looking at other types, we'll look at what that means in particular. So let's get started. Let's imagine, for example, that we are in a cafe. 4 people can sit around a rectangular table as shown. So it's pretty much one person to one edge. Okay. How can we combine two of these tables? Right, so we've got two options that can happen. So we can either have each table sitting side by side, or we can join them together. Okay, that's pretty much what we can have. How we join them together, we could do it that way, we could do short edge to short edge. Essentially, keep them separate or join them together. They are our two options. But if we can still only sit one person on each side, which way is going to give us more people? Okay, well, if we keep the tables separate but just move them closer together, that's still going to give us that space. Right? We're going to get 8 people round those tables, whereas if we join them together, we're only going to get 6. So for these patterns, what we're going to do is we're going to assume the first option. Right? We're going to look in another video about what happens if we choose the second option. Okay, but just now we're going to stick with the first one. So how many people will we have? How many people could we sit even if we had 3 tables? So we've got 3 tables, one person in each edge, we get 12 people. If we had 4 tables, we've got 4 people at each table, one on each edge, 4 tables, 4 people each, 16 people altogether. So what we're going to try and do is we're going to organise this information in a table. Right? What we don't want to have to do every time we're looking at these is we don't want to have to sit and draw out tables, for example. He says, ironically, we're going to draw this table. So what we've got on the top is the number of tables, and then on the bottom, the number of people. And what we want to do is we want to construct a formula so that if we can have some information, we can crunch our numbers and we can work out the answer to the other one without having to do a whole load of work. So what we're going to consider is what happens when we increase our tables. So when we go from 1 table to 2, we had 4 people, to 8, we've gone up by 4. We've added 4 on there. When we add in another table, we add in 4 more people. Add in another table again, we add in 4 more people. And so what we're doing is we're thinking of a pattern that we know goes up in 4s. Okay, and the pattern that we should be thinking of is the 4 times table. And in fact, what we find is we've just taken the number of tables, multiplied it by 4, and that gives me the answer in the bottom row. So if I was to try and make that into a formula, how would I do it? Well, the number of people that I get is equal to 4 times the number of tables. Okay, we don't want to have to write out all those words, so we can shorten it using the letters that make a bit of sense. So P for people equals 4 times T for tables. Okay, and we can shorten that even further if we want. P equals 4T. So looking at this one here, the missing number that went in that table there should have been 400. If we've got 100 tables and we can fit 4 people at each, 400 is the answer. So that one there, we could either have worked it kind of intuitively, or we could have done it more formally with the formula. But either way, hopefully that one makes a bit of sense as to where that number comes from. We were able to come up with 400 without having to draw out 100 tables and put a person in each edge and count up all the people. Okay. So how is this going to change if we change the table slightly? So now, rather than just sitting 4 people, someone's gone, wait a minute, that's a rectangle. If you just budge up a wee bit, we can fit 2 people on the longer side. So now, at each table, we can fit 6 people. So how is this going to change my pattern then? Well, if I've got 2 tables, I've got 12 people. If I've got 3 tables, I'm going to have 18 people. Okay, so the table still looks similar with the numbers in it here, but the number of people in the bottom row is changing. It's going up by more. So if we were to have 4 tables, we'd have 24 people in it. And so this time, we find that as we add on another table, we add on 6 more people. And so this time, we find that we're going up in 6s. Okay, a pattern that goes up in 6s, and the 6 times table. So if we were to find the number of people, we're going to do 6 times the number of tables. So shorthand, P equals 6 times T. P equals 6t. And so if we've got 100 tables, and we want to find how many people could sit around them, 100 times 6 is 600. Okay, so the same idea, just slightly different numbers this time. So how can we use this to help? What's the point in this? What are we doing? Well, what we want to do is we want to be able to answer these questions and solve these problems without having to draw out so many pictures. Okay, so we want to be able to use the formula, crunch the numbers, and just get an answer. So what we might want to know is, if we consider the tables we've just looked at there, how many people can we sit at 24 tables? Okay, so we're having some kind of reception or dinner. There are 24 tables available to us. How many people can we invite to this? Or if there are 72 guests coming, how many tables will we actually need? So think about the first one. I've got my formula, so P equals 6 times T, so number of people, 6 times the number of tables. How many tables did I have? I had 24, so the next line I'm going to substitute in my number. P equals 6 times 24, and 6 times 24 is 144. So P, number of people, turns out to be 144 people that we can set around 24 tables. Think about the next one. First thing I'm going to do, write in my formula, P equals 6 times T. I'm going to substitute in my number, only this time I know the number of people. So this time I've got 72 is equal to 6 multiplied by something. Okay, 6 times what is 72? 6 times 12 is 72, and so the number of tables that we need here are 12. Okay, so if I have 12 tables, I could fit 6 at each, gives me the 72 altogether that I needed. Okay, and what we didn't have to do this time is we didn't have to draw out 24 tables and count all the little people around it, because that would take far too long to do. And alternatively, we didn't have to draw out lots and lots of tables and keep adding people until we added 72 and then check to see how many we did. Okay, so this way needs to provide us with a quicker way of doing it than drawing out the tables.